So the last thing I want to do in this discussion is talk about the test driver that sets all the wheels in motion, and then we'll run the program and you can see what it actually does. So this is a test. It's called PrimeCheckTest. You can see it's annotated with a Spring Boot test annotation, which says treat this as something that can be used as a test, a generator of calls from the client to the server. And of course, it's going to kind of let the PrimeCheckClient we just saw do the actual work of communicating with the server. And the server, of course, will be the front end of the server is handled by the PrimeCheckController. We have to give it some indication of where to find the various classes that are used as part of the implementation. And this is all part of the dependency injection model. So that's where to go look to find the various components to inject. For example, there's something called components where we define some beans. And beans are basically, think of them as like factory methods, if you will, or annotations that indicate something as a factory method. So for example, there's one place that we took a look at when we talked about the PrimeCheckClient, where we had this REST template, which was auto-wired. And over here, you can see that the components class, which is the name I gave it, we could call it whatever we want. This has a bean that knows how to make a REST template. And likewise, we also have a bean that knows how to make a PrimeCheck service. And that was what was used by the PrimeCheckController in its auto-wired field that mapped the PrimeCheckController to the PrimeCheck service. And the get PrimeCheck service factory method is what was used by the dependency injection portion of Spring to wire those things together. The basic idea of a dependency injection is you don't have to write explicit constructors. You let the build and configuration process do the creation of those objects and the auto wiring of them together. So let's come back over here and take a look at our PrimeCheckTest. We're going to have an auto wired field called PrimeCheckClient. We've already looked at PrimeCheckClient. That's the thing that does to test individual calls and test list call. And this is what is going to actually drive that PrimeCheckClient in ways you'll see in a minute. It's really cool. We define ourselves a little field called margv, which is just going to keep track of the command line arguments we want to pass in. In this case, we want to turn debugging on, and we want to have some number of integers sent. Let's make them 50 just to make it somewhat interesting. So here is the test method. This is how a Spring Boot test works. You annotate a method to say it's a test method, which says it'll be automatically run when the test starts to run. And in this particular case, the run test method will print out that it's starting up. We'll then go ahead and parse the command line arguments, which is what we pass in over here. There is no command line for a test, so we have to set that ourselves. We're then going to generate some number of random integers. And this is the method that does that. It's called generate random numbers. We use the random class in Java. We generate a stream of random integers, which will be count in length, and count is what's set by this parameter up here. So we're going to make it be 50. So we're going to generate count of these guys. Let's go back and find that. So here's count. We're going to have, say, 50 of them, which is a parameter. And we're going to have them range in value from some max value minus the number of integers we're going to generate up to the max value. So and max value is a very large number. So we're generating very large random integers. And that's because that will take a while to check for primality, because it takes a while to check for the primality of large integers. We then take each of these ints and we convert them into an integer. That's called boxing. And then we collect those boxed integers up into a list. And that's what gets returned from generate random numbers. You can see here that we stash aside the random integers, and then we're going to reuse those and pass them to all the different test methods. And the reason for doing this is to make sure we're always testing exactly the same input. And we do that because that way our timing results will actually be comparing apples to apples. So now we're going to do some really, really cool modern functional programming Java stuff. We're going to make a call to this method called timeTest. And timeTest is going to check to see whether or not it's going to send individual, in this particular case, it's going to send individual requests to the server to check if an integer is prime or not. And it's going to do it sequentially. Let me get rid of this stupid thing. I hate this. So as you'll see here, the timeTest method is going to time the amount of time it takes to send individual calls with this list of random integers sequentially, and we're going to pass in a debugging string that we can use to identify this was the individual calls sequential test method. So let's go ahead and take a look at time test after I show you what else we do. So we call time test to test individual calls. We also do time test to test a list call, once again sequentially. So the first two calls are going to be individual calls or list call sequentially. And then we're going to use time test to test individual calls using parallel processing on the client side. So the individual calls will be called on the client side with a parallel stream. And then finally, we're going to test this with the list call passing in true, which says use parallel streams on the server side. This call up here will call sequential streams on the server side. This call here will do parallel streams on the server side. And we're going to see how that affects performance. When we're all done, we're going to take the results of all those tests and see which ones ran the best and which ones ran the worst. And I'll let you surmise which you think will perform the best as we talk through this. So let's go ahead and take a look at time test. So time test is a helper method, which takes in a by function, which in this case would be something like, test individual calls or test list call. A by function is just a function that takes two parameters, and those parameters will be a list of integers to test and a Boolean to indicate whether we want it to be parallel or sequential, and then a return type, which is just void because we don't care about the result. We also take in the list of prime candidates, whether we're parallel or not, and the name of the test. And then we do some cool magic we call a little helper method that's part of the run timer utility class. And it's going to take a measurement of how long it takes to run the test. So we're going to call this method called run test, passing in the by function we want to test, the prime candidates we want to test on, whether we're parallel or sequential, and the name of the test. So first, let's take a look at Let's take a look at time run. Here's what time run does. We give it a supplier and a name of a test. We start the timer running, which just figures out the nano time and records it. We make a get method call on the supplier, which runs whatever test we're doing, which will be test individual call, test list call, and so on. We then stop the timer, and then we put into a results map, which is just a hash map that maps the name of the test and the result in nanoseconds. We put that into a hash map so that the test name will indicate how long it took to run. So that's what time run does. And then run test is simply going to take this by function test, and it will print out a diagnostic indicating we're starting, what test we're doing, how many count integers we're going to be testing. And then we take the by function, we apply it. Apply is just the method that's called on a by function, passing in the prime candidates and the flag that indicates whether this is going to be parallel or not. So that's what run test is. Marvel for a moment at how refactored this code is. So we've got this one method called run test, which is parameterized by a by function, which is called by time test, and time test uses this time run method so we can time everything in a very convenient way. And then all those things get called here in a very systematic manner. So there's no extra code. It's all nicely refactored, nicely normalized, and everything's going to be super easy to measure in a nice apples to apples way. So that's basically what the code looks like for the test driver. Now let's go ahead and run the program and see how it performs. So the first thing we have to do is shut down the previous run. So that stops that. Now we're going to go up here and we're going to select the PrimeCheck application and we're going to run it. And we do that by clicking the little green arrow. And that's going to hopefully compile everything and it'll start up the server. So now at this point, we've started the server. The Prime controller is ready to go, waiting for requests to come in from the client. We then come over here and run the PrimeCheck test. That's what's actually going to run that driver program. And that's going to go ahead and start up, and it's going to start doing the various tests that we want to run. So it'll start by hopefully compiling, and you can see it starts out by doing the individual calls sequentially for 50 randomly generated large integers, and that's going to run for a little while. And then when that's done, it prints out the results. You can see we turned debugging on, so it'll tell us what the results were. Things that have a 0 were prime numbers. The other things show their smallest factors. Then we run the list call sequential with a count of 50, and that does the same behavior, but it does it with a list instead of sending each request individually. Then we come down here and we're going to run the individual calls in parallel on the client side. So we're going to do parallel calls to the server from the client. And then the final thing we're going to do is we're going to do parallel calls, having the server run in parallel using a parallel stream. So all those things went off, did their thing. We got the results back. And now we're going to see how long they took to run. And this is what we get back from our little use of the run timer helper class. So you can see, as you probably would suspect, that list call parallel ran the fastest. And that's because it was doing parallel processing on the server side. And so each request that came over there was a list of prime candidates, and those were run in parallel using parallel streams. And I've got 16 virtual cores on my Mac, so it runs it very quickly. So we were basically getting the boost of parallel processing with embarrassingly parallel algorithm in that case. Individual calls parallel did individual calls, but it ran it in parallel on the client side. So each individual call was run in parallel. And you can see that ran slower than list call parallel, which we'd expect because there's latency overhead of doing all those two-way requests synchronously. But it performs better than either of the sequential implementations. List call sequential sent the list over to the server and then ran it sequentially over there. And you can see how long that took to run. And then finally, individual calls sequential did all the individual calls on the client side sequentially. And of course, that had the most latency because it was all these two-way requests for 50 random integers. So the results are kind of what you'd expect. The parallel streams approach that had you send all the prime candidates in one fell swoop ran the best, and then the other ones performed less best. But it's still, it worked. So all the code functioned properly. It's just that we were getting things to run a little faster by using parallelism. And then this is what you see on the server side. If you go look at the instrumentation over there, you can see the results that are printed out on the server side. And if I turn off the debugging, we'd see better performance, but we'd see, I think, relatively the same performance differences for the different results that we were comparing.